Hey everybody, it looks like we're live, so guess we can start kicking things off. My name is Sabin Adams. I'm a developer advocate here at Prisma, and yeah, we're super excited to be kicking off this new event series called Serverless Deep Dive. And what sort of sparked us to want to start this series is just that Prisma has sort of shifted its focus more into the serverless world. We believe that's the future of deployments, and we feel like there's a lot of not misinformation, but there's a lot of confusion around the world because there's so much information to digest about serverless in general. So the goal of this event is going to be basically to get professionals who are working in the field and just sort of bring our minds together so that we could talk about the serverless ecosystem, how it's evolving, how it's changing, how we see it moving in the future, and then just the general conversation about the developer experience and stuff like that. So we are super excited today to have a couple of awesome speakers with us. We've got Jeremy Daly, who's working on Amped, and Alex DeBrie. And so they'll be giving a couple talks, and then at the end, we'll be having a nice panel discussion. And during that panel, we're going to be answering any questions that you might have for us. So please, if you have questions, leave them in the comments, and we'll be sure to try to get to those near the end. That'll be near the end of the session, so that'll probably start at around 11 PST, I think. So anytime before then, just throw your questions in the comments, and we'll be gathering them up and getting prepared for them. So I think our first speaker here is going to be Alex DeBrie. So I'll go ahead and bring his camera on stage and introduce him a little bit.
Hey, Sabin.
Hey. So how are you doing today, Alex?
I'm doing well. I'm excited. Thanks for having me here.
Yeah, of course. No, this is exciting. I am very excited to hear what you have to say. And I think I'll just go ahead and pull myself off. And if you're ready, we can go ahead and get started with your session.
Yep, absolutely. Will you pull my slides up too?
Yeah, for sure.
Cool. Awesome. So I assume you can all see my slides. Yeah, I'm Alex DeBrie. I'm excited to be here. Sort of leading up to this, Sabin's like, hey, you want to come on, talk about serverless, talk about databases. Like, I love both those topics. Been sort of thinking about those topics for a few years now. So absolutely want to do that. Right after I got off with Sabin, I sort of went to ChatGPT and typed in my summary of what I thought the topic would be about and said, hey, give me some titles. And the first title that came up was, hey, serverless databases, a match made in heaven or in hell. I think that's a little over the top and extreme and things like that. So I decided not to go with that topic, but just talking about serverless and databases, I'm more optimistic now than I have been in a few years. So I went with, hey, it's better than it used to be, right? There's some hope, there's some reason for optimism coming on the scene here. So I'm going to talk about serverless, using databases within serverless. When Sarah and I were initially talking, I was going to really focus on sort of database connections specifically. And I was thinking a lot of practical advice on what you should do there. And I tweaked it a little bit just for a couple of reasons. Like, number one, there's a lot of great material out there, including some Sabin's written this week and other things on how to do it for different environments. But also just because I think serverless is sort of spread out a little bit. There's a lot of different patterns and tools and things that people are using to where practical advice might not hit everyone. So I wanted to sort of look at this historically, see some stuff where we've been in the past, maybe some advice you'll hear and whether that's still outdated or not, or at least how to conceptualize and think about this stuff. And then think about, hey, some recent developments that are really changing how we should be thinking about this. And then what does that look like going forward? So we'll start with, in the beginning, some historical stuff, just some background on serverless and thinking about that. The two technology triggers we have that are more recent, and then to the edge and back. As Sabin said, I'm Alex DeBrie. I do AWS consulting. I do a lot with DynamoDB. Not going to talk a lot about Dynamo in this talk, but if you like Dynamo, hey, reach out. I'd be happy to chat about with you. But I'm just generally a serverless and database fan. Cool. So let's start with in the beginning and really what's the fuss about database connections in serverless? Because this is something you'll hear a lot from people, and why is this such a big issue? And the serverless era really begins in sort of 2014 when AWS Lambda comes out, right? And it's this new sort of computing paradigm called serverless compute. I think the big, interesting, different part about it is that it's event-based. And I like to say event-based rather than event-driven, because event-driven has this other terminology that people, that means something else, but overlaps in some ways. But event-based, what does it mean for event-based compute? I think there are three interesting characteristics there. number one, like instances are going to be created on demand when they're needed, right? So if you have a web application that you're running in Lambda and someone makes an HTTP request to that application, there might not be an instance of that running, right? They might need to, while that connection is just sort of waiting for a response, download your code, start it up, initialize all that stuff before it can actually process that request, right? So they're created on demand when needed. And also each of these instances are going to be processing one event at a time, which is really easy, I think, to wrap your sort of mental model around how that works. You don't have to think about concurrency across events or different things like that. But it does mean you'll have sort of more instances of these events, right? If 5 requests come in at the same time, it's going to have to start up 5 different instances of those requests to handle that. But while it can only do one event at a single time, one instance can serve multiple requests over a long period of time, right? So you get function reuse in that sense, right? So if a request comes in, it has to download all that code, initialize, and serves that response back. And then another request comes in, it can go to that already running container there and be a little bit faster for the next one. So just in terms of terminology, like if you're newer to this space, right? When you hear about a cold start, that's when that instance is created on demand when needed. That first time that instance spins up, that's going to be a cold start. But then if you hit a function instance that's already live, that's where you call a warm invoke, where you're hitting an instance that's already live. You don't have to pay that real cold start penalty. And then so thinking about what's happening within that Lambda invocation, right? When a Lambda gets invoked, what's going on in there? I like to break that down into 3 different steps, right? You have the initialization of the process itself, which means, hey, some computer somewhere has to download your function code. It has to create a micro VM. It has to start your process, which if you're using Node, that's going to be a Node interpreter. If you're looking at Node, that's probably about 160 milliseconds. And if you want more details on different runtimes, things like that, I recommend this resource from Maxime David. He works for Datadog. Really cool, like cold start analysis of all these different runtimes across Lambda. But looking at about 160 milliseconds for Node.js, which isn't great. It's not the end of the world. That's not what's going to kill you. I think what really kills a lot of people on the cold starts is that next step, which is the code initialization, right? What sort of dependencies are you pulling in and loading from disk on that cold start? What classes are you initializing? Things like that. If you're running an Express web app, you're starting up that Express server, or maybe Apollo, you got an Apollo router and things like that. And that can really vary quite a bit there. It could be as low as 10 milliseconds if you're writing pretty skinny Lambda functions, but it can also be 10 seconds or more if you have like some really fat dependencies in there. And then once that code is initialized, right, now you have your actual code execution. What are you doing? Are you saving a record to a database, pulling it from a database, inserting something into a queue, something like that? Again, highly variable, but that can be, under 10 milliseconds to a few seconds, depending on sort of what work you're doing. So that's what's all happening within a Lambda invocation. I just want to note, like, all of these things have to happen on a cold start, and that's what gets people tied up on that cold start, because this can really start to stack on each other and take a long time. But the good news is, like, a lot of that stuff is reusable. That process initialization or all that code initialization that you're doing is reusable across requests, right? And now on a warm invoke, you're just doing your actual code execution, the stuff you actually care about, and it's much faster there. And so if we're talking about like cold starts versus warm invokes, if I'm working with clients and looking at performance targets for like user facing Lambda functions where there's like an HTTP request waiting on that, what am I looking at? I usually say, try and get your cold start under 1 second. The thing is, like, cold starts aren't going to happen all the time. If you have one that takes, 800, 900 milliseconds, and that's not the end of the world. But I do think you get into those situations where people really start to get mad is, if it gets to be 3 seconds, 4 seconds, 8 seconds, things like that, that's where it becomes a deal breaker, because now you have, like, your site just looks sloppy if you have people coming, waiting on a request for 5, 10 seconds on that sort of thing. And that's where your cold starts really get bad. But then on a warm invoke, you should be looking at under 50 milliseconds, depending on what you're doing. But if it's just sort of reading, writing to and from a database, like that should be pretty quick for you. All right, so that's some just like high level background on serverless compute, some of its unique challenges, terminology, get us on the same page. Now let's talk about the initial problems with sort of traditional databases that we saw in the serverless world. And this really describes sort of 2014 to 2020, 21, I would say, is where this was really a problem. And when I talk about traditional databases, I'm talking about Postgres, MySQL, a little bit like Mongo and maybe Redis or things like that are where these issues come up. The first problem is that these databases often require a VPC. So this is AWS's virtual private network construct that it's basically setting up for you, right? Where your database is not going to be publicly accessible to the public internet, right? And so it's within this private network, but that means it wants your compute in that private network as well, including your Lambda function. Well, putting your Lambda function in a VPC adds like a 10 to 15 second cold start initially, right? Because they have to also spin up this like networking infrastructure and attach this network interface to your Lambda function. That was all happening on demand as your function was spun up. So it was really slow, and you're getting into that place, which was just like a total deal breaker, right? You couldn't afford to use a relational database in a VPC with your Lambda in a VPC in like a user-facing environment because that cold start was so slow. Now, the good thing here is like this is no longer true. This is fixed in 2019. So just like if you're looking at stuff out there and you hear about VPC cold starts and it being an issue, like you can sort of toss that information away. That's outdated. That's old. I still like to avoid VPCs for other reasons around complexity and just like the types of architectures you end up building, but you don't have that sort of cold start issue really holding you back anymore. However, you do still have the connection limit issue, right? And basically what this is especially with Postgres and MySQL, they have like a limited number of connections you can make to that database. And part of that is like Postgres, you know, they spin up a process per connection. MySQL does like a thread per connection, but there's often like, you know, using a lot of memory within that thread as it's executing queries that can really impact your database performance. So especially with those ones, you want to limit the number of connections you have out, you know, 50, 100, 200, something like that. But there's a problem just in terms of how that Lambda compute model works that as it relates to like setting up those connections, right? And there are three sort of combining factors with Lambda that gives you a problem with connections. And first is, hey, you're only doing one event per function instance. So if you have 5 requests come in around the same time, it's going to spin up 5 different function instances, and each one is going to need to set up a connection to your database, right? So that's going to be 5 connections. Even though it's only 5 requests, that's not that many. That could easily be handled on like a very small node server that could do connection pooling across it and set up, you know, 1 connection or 2 connections, things like that. So that's one issue. Another issue is, you know, we talked about that sort of cold start initialization, especially like the amount of code you're packing into your function. And what people saw is like, hey, if you're putting your entire web app into a single function, you're going to get a lot longer cold start time, that code initialization step. So then if you have a web app with 50 different endpoints, rather than having one function running an express app that's handling all those endpoints, you might have 50 different Lambda functions, each one handling a separate endpoint. Right? And that's going to help your cold start boot up time and things like that. But what it's also going to do is explode the number of connections, because now you have all these different functions, each of which have all these different instances to handle one event per function instance. So where you could have handled, you know, a reasonable number of traffic on a pretty small number of like container instances or servers, now you might have 200 Lambda functions also handling that, each one setting up a connection to your database and sort of overwhelming your database. And the last factor we have here is like, we want to reuse as much as possible from that cold start to our warm invoke. And that means, you know, installing our dependencies, setting up our classes and things like that, but also connecting to our database, right? Because connecting to our database takes time, because you got to do, you know, if you're talking about MySQL, that's probably 4 or 5 round trip connections, depending on you know, what TLS you're using, what sort of auth you're using, but 4 and 5 round trips between your Lambda function and your database server. And you want to do that as few times as possible, you know, ideally just on that cold start invocation, and reuse that connection across those invokes, right? So all these things tying together, right? We have lots of different function instances per function. We have lots of different functions because we're splitting them out into smaller isolated pieces of work. And then we want to reuse that connection across multiple instances, led to like very easily overwhelming your database. So that's just like, again, sort of the overview. And I would say in 2020, 2021, somewhere around there, like where were we with using relational databases in a serverless environment? I'd say the good news is like VPC cold starts are fixed. You don't have to worry about that sort of deal breaker cold start issue anymore. But the connection issue is still an issue, right? And there are some band-aids for that sort of thing, but none of them are really great. And I would say fixing this need as well as we want to. And some of those band-aids would be like RDS proxy, where AWS releases this it's basically like a connection pooler that sits between your Lambda functions and your relational database, and your functions connect to that. There's some pooling within the RDS proxy so you don't overwhelm your backend database. Like, that's great, but now I have additional infrastructure I'm thinking about. I already don't want to be running these things, and now I'm running more of them. It's harder to have sort of per user environments because it's expensive, all sorts of things like that. Another option is Serverless Aurora Data API. So Serverless Aurora is like this relational database provided by Amazon. They put a data API on it, which is basically an HTTP-based API to connect to it. You don't need to put it into VPC. You don't need to worry about connection limits as much. But there's some bad perf characteristics around that data API to where it might be quicker to actually just like open and close a connection every time anyway. And I would say Serverless Aurora is sort of not so serverless in a lot of ways and frustrating to use for different reasons. And then so I think what a lot of people were doing was just closing the connection on every single invocation, right? If you invoke a Lambda function, it connects to your database, it runs a couple queries, and then it closes it at the end of it. And that's nice because now you're not overwhelming your database with connections by holding these open, but it also means on every single invoke, you need to recreate that connection to your database and pay that 4 or 5 round trip time to make that connection. So these are all band-aids. I would say none of them sort of satisfactorily fix that solution. The last option is Dynamo, and I'm not here to like pump Dynamo, but like, this is why I got into Dynamo, and a lot of people got into Dynamo is because like, hey, you don't need a VPC, you don't have to worry about these connection limits. Like, I like other things about Dynamo as well now, but this is like what really introduced Dynamo to a lot of people. And I think this history around some of this stuff, like understanding the VPC issue, understanding the connection limit issues, understanding why people chose Dynamo, I think is helpful if you're sort of new to this space. So 2021, I wasn't feeling great, and I wasn't feeling sort of optimistic about relational databases in serverless environments still. I think there was still just a lot of complications. But in the last couple of years, I think there have been 2 technology triggers that have really changed the game on this and like have made me more excited going forward. So the first change is just like in databases, database infrastructure itself. And I think this is a really hot, like changing area right now. I just want to do like a truncated history of databases. We're not covering everything here, but if you look back in like late 70s, Oracle's coming online, and then you have the 80s and 90s, Postgres and MySQL. These are all great databases, right? They're still used. Go to DB engines. These are like far and away the highest ranked databases, and they're going to solve a lot of problems for you. So like, you can use these databases, but notice when they were built, like they're all built before 2006, when like AWS launches, the cloud sort of becomes a bigger thing. And like 2006 is still pretty early in that, but it's starting to change how we architect our applications. And it's also changing how we architect, or like what infrastructure we can use. And again, it took a while for this to sort of develop. 2009, we have Mongo and Redis come out, but like, I want to classify those as like really cloud native databases, right? Like all those are work really well in data centers as well, on-prem, things like that. Mongo's got some horizontal sharding stuff that's pretty nice and helps to have a cloud, but it's not sort of just like cloud native in a way that other things are. But I would say like, if you look at 2014, that's when like this earthquake happens, I think, right? Where Snowflake comes out, and this is this data warehouse, totally cloud native, like could not run in a data center. It's relying on S3 or different blob storages. Now it has sort of scale in, scale out compute. It's pay-per-use on all these sorts of things. And it's really just like, this is something that could only be built in the cloud environment. It wouldn't have made sense in a pre-cloud world. And it gives you some benefits that are just like impossible and really unique and fit really well with a more cloud first mindset, right? So I think that started to change things, and we start seeing more databases follow this sort of pattern, right? We see PlanetScale in 2018, 2019, making Vitess like available to the masses. And now just in like the last year or two, we've had like a bunch more of them, like databases talking Neon, Terso, Zata. If you're talking caches, you got Memento and Upstash offering those sort of things, right? So we've got like this amazing set of like cloud native databases, data stores that are coming out. When I think of the characteristics of those, I would say, 3 things really pop out. One, like managed SaaS, right? Often these are available as a managed SaaS offering, perhaps only as a managed SaaS. Sometime it's an option. You can also have it run yourself, but I think that changes a little bit of what they can do there. Also, you have just like more dynamic scalability, right? They're sort of built for the dynamism, the elasticity of the cloud, rather than like a more fixed mindset of a data center. And then there's usually some element of multi-tenancy, and it might be multi-tenancy across the entire database, like DynamoDB is, like Fauna, like Upstash, Memento. It might be multi-tenancy in some places, more single tenant in another. I believe that's how like PlanetScale works on some of that stuff, maybe Neon as well. But there's at least some element of multi-tenancy and probably some like load balancing layer that says, hey, connection limits, might not be as big an issue as when you sort of have a dedicated single tenant instance as you did before. So this is the first big technology trigger, right? We have these different databases coming up, but then we have another technology trigger happening around the same time. This is Cloudflare Workers, right? Giving us sort of a new type of serverless compute. We call this edge compute, I suppose, and this is getting to be a confusing area, but I think there are two elements of edge compute, right? Number one is it's actually distributed around the edge, right? It's closer to your users. Cloudflare now is like 285 cities around the globe, right? So no matter where you are, me in Nebraska, Jeremy out in Massachusetts, people in Singapore, wherever, they're going to hit something that's very close to them. They don't have to call into Northern Virginia or Ireland or Oregon every single time, right? So we have that aspect of the edge compute. And then also, while it's on the edge, it changed just how, like, what that runtime looks like, right? It's still running JavaScript, but it's not like a full node environment, right? It's using these V8 isolates rather than sort of the micro VMs of Firecracker. You have these faster cold starts, nearly instant cold starts, and depending on some of the terminology there, like potentially instant. But it's just like a different environment where that 160 millisecond cold start that you were having in Lambda, you're not having to pay on these edge computes, right? So that's all going away, right? That's much lower with Cloudflare Workers. As this sort of starts, right, this is initially aimed at pretty stateless work, things like header manipulation, redirects, TLS check, making sure you have a high enough version of TLS. But like, the thing about JavaScript developers is like, hey, we want to expand everything to everything, right? And it never stops there, right? We want to run full web apps on the edge, do all this sort of stuff. And it runs into this issue of just like that database connection issue again, right? Like if I'm running a web app at all these different locations around the world, how am I connecting to my database? And one thing that's interesting about Cloudflare Workers is it only allows HTTPS outbound connection. It doesn't allow like raw TCP connections, which is like kind of weird to me because like HTTP and HTTPS are TCP under the hood. I think part of it, like just looking at there's a post like a year and a half ago from James Snell, awesome guy at Cloudflare, talking about sort of that decision a little bit. And it sounds like they want more of a standard around connecting with TCP in JavaScript and things like that. So I'm not sure where we're at with that. But basically, you're in this world where, hey, we have this edge compute. We're going to have lots of different instances spinning up, and we can only make HTTP connections. Like, how can we make that work with the database? And then you have all these cloud native databases, these managed multi-tenant databases saying like, how can we siphon users from wherever that energy is and pull that in? And you see like all these databases step up, I think, right? Where like PlanetScale has this blog post about how they can handle 1 million connections to MySQL and it doesn't change performance, right? Which is just unthinkable with sort of vanilla MySQL. And they've also got this like database library in NPM and GitHub that you can use to connect to PlanetScale over HTTP. You don't need to connect over TCP. So now it works in things like Cloudflare Workers, Vercel Edge, things like that. And you see the same thing with Neon. They've got like a WebSockets thing that allows you to connect to your Neon database. Upstash has a thing that allows you just to connect over HTTP. And like my new favorite website, this Edge Data Latency, I think this is super cool to look at, but it's basically like there are like 10 different databases configured. You can pick one and just sort of check the latency of what it looks like to do these responses connecting to these databases. And the thing is, all these databases in there, PlanetScale, Neon, Upstash, Tigris, Superbase, all these like have to have HTTP connections and basically have to be able to handle lots of HTTP connections in order to work on these things. So this is really cool. I'm like super excited about this stuff. So what I would say is like, I think those two technology triggers, these cloud native databases that could enable more sort of connections to their underlying database, weren't sort of constrained by that single tenant nature of the traditional databases. And then also the demand side from Cloudflare Worker users and just serverless users in general has like really advanced stuff, right? So today now we have like two flavors of serverless compute. We have that Lambda-based stuff. If you're using Vercel, that's Vercel Serverless, right? Which is more sort of like micro VM based, a little higher cold start, but a little more predictability, a little more flexible and capable in what it can do. You also have Cloudflare Workers, or if you're using Vercel, the edge runtime, lower cold starts, a little more constrained in what it can do, but pretty interesting there. And then we also just have many, many database options that allow for these unlimited connections and for this stuff, to where I think this is becoming less and less of an issue, right? At least the number of connections is an issue. So just closing off with like to the edge and back, like, should I just use the edge for everything and distribute everything around the world? I think there's been some great discussion around this, and even like Vercel folks are telling you, hey, like, don't do everything on the edge. I think there are some outstanding problems on the edge still. And one of the big ones is just going to be connection latency, right? If you need to set up a connection from your serverless compute, wherever that's running, to your database, that's going to require multiple round trips. Even if you're using HTTPS and HTTP2, like, we're talking at least 2 round trips for that sort of thing, right? And that's going to be a lot. That's not executing your business logic. That's just setting up that connection. And if we're talking about those round trips, you can go to cloudping.co to see like how much that is. But like across the US, Northern Virginia to Oregon, that's 63 milliseconds. Across the ocean, Northern Virginia to Ireland, that's 70 milliseconds. Northern Virginia to Singapore, that's going to be 200 and some milliseconds, right? So this is going to add up if you have to do 2 or 3 round trips on that particular request. That's where you really want to be able to like keep that connection alive and get use of that warm invoke, right? And that's where Lambda, I still really like Lambda, because I think that cold start, that warm invoke, I would say predictability and understandability is very real. Like, if you look in the AWS docs, they'll tell you like less than 1% of Lambda invokes are cold starts. And that generally tracks with what I've seen, depending on sort of your usage patterns. Like, I'll check these a lot with clients when I start with them. Like, for example, I truly had this recently. I had a client, I looked at their requests over a 12-hour span. They had 91,000 invokes on one of their functions. 91,000, out of that, only 27 of those were cold starts. So we're talking like 0.03% there are cold starts. And like, so if you have pretty persistent traffic like that, cold starts aren't gonna be that big a deal, as long as you're not into that like really deal breaker, 5-10 second cold start range. Like, those cold starts aren't going to kill you. And that's where being able to reuse those connections is going to help you, because now you're talking about taking off 20 to 50 milliseconds on every single request of a warm invoke. Now, when you think about cold starts, like, Cloudflare Workers doesn't really have like that process initialization cold start, but you're going to have like, you still have that connection initialization, your code initialization. And if you have 285 locations around the world, you're going to have more cold starts generally. My assumption is, right, like if I'm in Nebraska, I was doing some testing, I'm hitting a Chicago edge node and going to onto the Cloudflare network. But if I have a friend in Dallas, right, they're going to be hitting something in Dallas. Someone in Singapore is going to be hitting something in Singapore, and you're just going to have more function instances around all these different edge locations that each have to set up those database connections. And again, we're not worrying about the connection taking up resources on the server anymore, but just the latency of establishing that connection is going to be real if you have more cold starts there. So my assumption is you're going to see a lot more cold starts on these sort of edge ones. I'd love to hear more like real life experience with this. So if anyone has any resources on this, wants to point it to me, like send it to me. I did some testing myself and it was interesting, but I'd love to see like what sort of cold start percentage you should expect if you have, a globally distributed app with 285 edge locations there. The last thing is like, hey, why do we have to go back to our database in Northern Virginia or whatever? Why can't we, just like we distribute our compute, also distribute our database? And we're seeing some interesting progress in that area. Like Terso is the one that I think has a lot of noise right now with SQLite being able to distribute everywhere. FaunaDB has been doing this for quite a while and enabling you to, rather than paying a 200 millisecond round trip latency from Singapore to Northern Virginia, maybe you have it one in the Asia Pacific where it's a lot lower connection latency there. Those are interesting. I'd check those out. They're not going to be right for all situations. I think your developers need to understand some trade-offs. It needs to work right for your app, but check it out. I don't think we're quite there yet, but it's an interesting thing to sort of keep an eye on. Anyway, I talked quickly. I hope that was helpful. Just like as a survey, I had a lot I wanted to say, but like my key takeaways here is like, there's a rising tide lifting all boats here. Whether you're using Lambda, whether you're using Cloudflare Workers, whether you're using some mix with Vercel, all that sort of stuff, like we have all these new database vendors that are aware of this connection limit issue and are working around it to where like that's not a deal breaker anymore like it used to be, just like 3, 4, 5 years ago, which is great. And then I would just say, when you're thinking about performance and all this stuff, like think holistically and make sure you're really considering the different factors here. Like the fact of like the process cold starts, like the cold start of starting up that Lambda process, 160 milliseconds, that's real. But like, how often are you actually cold starting, right? And if you're doing it less than 1% of the time, that 160 milliseconds isn't your killer there, right? What really kills you is that code initialization time that's happening in your Lambda function. And that's where you see people go to 3, 5, 7, 8 seconds of cold start. And they're thinking, maybe I won't get that on Cloudflare Workers, but like, if you have the same code in your Lambda function as in your Cloudflare Workers, it's going to take that long to cold start as well. One thing that's nice about Cloudflare Workers is like they put some constraints on you on how big your function code can be, how much time you can have to actually execute that stuff, to where people I think are creating skinnier functions and seeing faster cold starts. But you can do the exact same thing in Lambda and get the same results. So like look at what you're packing into your function and be judicious about that, because if you're getting really long cold starts, that rather than the process being started itself is what's really killing you. And then think about connection initialization as well, right? If you're on the edge and you have to set up a connection all these different times, like those round trips are gonna hurt you, and that's gonna be more important if your function is far from your database. I don't know if we have time for questions. I think we'll probably just move on to the next one. But hey, if you do have any questions for me, like I'm available on Twitter, I'm available on website, email, all that stuff. So feel free to reach out anytime. Yeah.
Hey, that was awesome. Thank you so much. I know listening to that, I learned a lot. And that's honestly, I was super excited for these events because just listening to you and coming up, Jeremy, I know all the listeners are going to learn a lot, but so am I. So that was really cool. I really like the point you made about latency on the edge, about how you want to hear other people's experience with the connection latency that they're experiencing and all of those things. I know that's a big thing at Prisma that we're also very interested in. It's a direction that we're examining very closely right now. So I would be curious as well to see just what people are experiencing as they push further into those things.
Yep, absolutely.
Well, let's see. You'd mentioned questions. We do have the panel at the end. So if anyone does have questions, you can also put them in the comments and we'll try to get to them during the panel. But in the meantime, thanks so much, Alex. We'll see you back up in just a little bit.
Cool.
And after this quick transition, I'll bring up Jeremy.
Cool. Thanks, Sabin.
Yep. Hello.
Hey, what's going on, Sabin?
Hey, not a whole lot. Just having fun up here with Alex's last talk. That was very insightful. I really enjoyed that. But I'm excited to have you on too. So why don't you start off by just quickly just talking about who you are, what you do, and then we can get started.
Yeah, so I'm Jeremy Daly. I've been in tech for 25 plus years. Started a web development company out of my dorm room, and then sort of grew that into an agency with a whole hosting component. I was racking and stacking servers at co-location facilities, and managing our own email, things like that. Got into the cloud in 2009 with AWS. Discovered Lambda in 2014, 2015, and then just fell in love with the concept of serverless. And I've been doing that ever since. So I speak a lot, I write a lot. I've got a newsletter, a podcast, all those sort of things. I'm an AWS Serverless Hero, which is an amazing program that AWS offers. I've just love serverless. So I've been working with companies and startups that build with serverless applications or build serverless applications, and then actually went to work for Serverless Inc. back in 2020. I'm trying to remember the years here. Worked for them for a little while, built a product called Serverless Cloud, and we loved it so much that we ended up spinning it off and started Amped, and that's what we're doing now. So I'm trying to shill a little bit, but I'll use the platform when I can.
Right. No, that's awesome. That's really cool. I'm glad you mentioned some of your prior experience because I sort of in my early career, I did some of that, like managing physical servers on location as well, where you're actually touching those servers. And I think that's a lot of where the excitement with this evolution of deployment paradigm sort of comes, especially moving into serverless. So I think we'll have to circle back to that later because I definitely have some thoughts on that. But yeah, that's awesome. To get started on some of the conversation here, the main thing that I want to sort of talk about during this is just that I see on social media, I see on articles, blog posts, videos, that there's a lot of confusion about what serverless actually is. I feel like a lot of people sort of have half truths about it, half definitions that they've just gained as they read. So I'd like to ask you, as an actual professional who's been working in this for a long time, how would you describe serverless in general? What is it? Why is it important? All of that.
Well, I think you're right that serverless is sort of anything and anything you want it to be now, which is a little bit frustrating for those of us who've been doing it for a while. But I think that most of the confusion came originally from the idea of, there's still servers in serverless. Like, of course there are, like that, there has to be. But the idea is that you don't have to manage those servers. You don't have to install updates to those servers. And really early on in the beginning, it was that you didn't even have to worry about, provisioning or paying anything when those services weren't running. It was maybe a bit of an altruistic vision because sort of once you started leaping into other areas of compute and managed services, it became really difficult, I think, for a lot of cloud providers to provide that sort of on-demand without there being some level of provisioning involved, which is why we've gotten some weird services from AWS lately, like Aurora that Alex mentioned, as well as Neptune Serverless or Serverless Neptune, and then there's also OpenSearch Serverless, which is, costs $700 a month at a minimum. I mean, so there's some weird things like that. But I think that the best way to describe serverless, at least to me, is more around the mindset of how you're building applications, right? It's trying to remove as much friction and as much overhead from the development and the management process that you can. I mean, if you think about it, the wonderful people at AWS and Google Cloud and Azure and Cloudflare, they're going to do a much better job of running a massive cloud infrastructure than, maybe your team of 5 people is going to do, or even if you've got a bigger team. And so really with serverless, the big idea is I think, at least for me, is having that operational excellence that these cloud providers can bring to your applications. And then, as someone who, again, literally installed Spam Assassin on email servers, in 2001, that had to manage those types of things, like that was such a distraction from what we were trying to do, to have to go in and manage those things. Now, somebody has to do it, but but everybody doesn't have to do it themselves. And so the ability for you to have these services that run, that mostly take care of most of the configuration, most of the best practices, obviously keeping the services up and running, making sure that they're connected, making sure they're distributed, and that all those things are working the way they need to be. It frees up developers and even architects and DevOps people who are trying to automate other things and work on more important things. It frees them up from having to worry about those concerns. And so for me, you can say serverless is supposed to be infinitely scalable or elastic, or it's supposed to scale to 0, or there's no server maintenance. Those things are all great, but I still think of it as any type of service now that is really reducing that, what we call undifferentiated heavy lifting for you, and reducing that burden on developers and architects and ops people, I think is really where I would classify things being serverless.
Yeah, no, I really like that point, because one thing I see a lot is people who are just getting into serverless saying things like, oh, wow, this is going to get rid of DevOps jobs. Right. And that's always sort of in the back of my head. I'm like, oh, I guess it could. But then you think about it a little bit deeper. And the point you just made is great, where it won't get rid of them. It'll allow them to do their actual jobs instead of the tedious things that they don't really want to be doing.
Right, and if you think about DevOps too, and again, that it's a term that is, it's another term that probably means anything people want it to mean at this point. But I very much so think about, the DevOps people are the people who are working with. I mean, it's not really people; it's more of a practice. But it's that process and that practice of trying to make it easier for developers to get code from their desktop into production, to ship that code in a safe, scalable, reliable, way, but reducing that friction as well as secure. But I think that's one of the things where if I'm an ops person and maybe I'm on a DevOps team, whatever, I don't want to be spending my time trying to make sure that all the latest security patches are installed, or that I got to go and configure all these these routing tables and things like that. That just seems like a waste of time, when it'd be better served if I could build in better automation and better scripts and easier deployments and easier ways for my developers to go ahead and test things and launch their own environments and get those feedback loops faster. That to me is what you want to be focusing on. And I think serverless services take so much of that burden off of you that is something that gets us closer to that ideal.
Yeah, for sure. I've been looking a lot recently into just the history of these different deployment paradigms, and I think an interesting way that I found to think about it is that each paradigm has a different unit of value that you're basically deploying. Where if you look at back in the traditional on-premise bare metal deployments, your unit that you're deploying is that actual physical server. When you get into VMs and containerizations, it's your virtual environment or your container that you've pushed. And the cool thing about serverless is that now, instead of actually worrying about the environment around your code, you're instead just worried about your code, and you're pushing that. Your unit that you're actually deploying is just your code, and then it sort of provisions automatically. So I think it's cool to see how the responsibilities have shifted more onto the developers and their code, and the focus is less on worrying about how it's actually going to run.
Right, and I think you're definitely right about that. I mean, obviously the developer has taken on more responsibility, because not only is the developer responsible for the code that they write now, but often it's the services that their code is going to run on, or the services that their code interacts with, that they need to be responsible for. So again, even if it's DynamoDB, you're still responsible for, in your infrastructure as code or whatever you're using to do your deployments, you're responsible for specifying, I need this table. I need this table with this name. Here are the GSIs I want. Here are all the other characteristics of it, the deletion policy and stuff like that. So there's a lot of stuff that you have to know as a developer, and it becomes a little bit frustrating. But that's an interesting point you make about the unit of deployment, because that actually is a double-edged sword. And people who the traditional the traditional recommendation, and Alex mentioned this in his talk as well, is to deploy small, discrete, single-purpose functions, right? So rather than you thinking of some large monolith, even if you're thinking of a monolith in terms of it being a microservice, really the best practices, or at least what people try to tell you should do in serverless, is to take those individual pieces of that microservice and now break it down even further, so that every function does one thing and does one thing well. And that's really, really great, because everything's discrete. There's no single point of failure. If this particular service isn't running, whatever, then all these other ones are still working potentially and whatever. But now you have to think about a lot of functions. And you see, especially when you get larger organizations, thousands of Lambda functions. And then the question is, well, okay, how did we deploy this Lambda function? Where, and there's just a lot of things to think about. And again, if you're using something like Pulumi, or you're even using CloudFormation with custom modules or whatever they're called there, that will deploy other Lambda functions that do certain things for you. And you don't even know, you're like, where did that Lambda function come from? I remember when EventBridge first came out, you needed a custom module to do that, and there was a Lambda function showed up in my account, and it just happened to be a test account that I was able to see that there was this extra Lambda function. I'm like, what is this doing there? And I thought my account was compromised. And so the management of those things can get pretty dicey. And not only that, but you start adding in SQS queues and EventBridge and SNS and all these other services you're connecting to, VPCs, because you still want to connect to maybe an internal database or use some other services, and things get very, 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 very confusing, and it's a big ball of mud, with a lot of different services interacting with one another. So it's a lot to keep, sort of in your head, and I don't think there's necessarily a great way to keep all that stuff organized right now, other than just really, really good practices with documentation on your team.
Yeah, that's a perfect segue into the next point I wanted to make is how do you view the current developer experience when working in serverless apps, particularly in situations like you just mentioned, where maybe you're working in a large organization with a bunch of different things going on?
Yeah, I mean, I think, one of the things that's, another quote from Alex, just because I wrote this down, I thought it was funny. It's better than it used to be, right? And that's certainly true. I think it's better than it used to be in some respects, but it's also gotten more difficult, right? So, when you think of developer experience, I think of developer experience as really as how easy is it for the developers to do their core job, which is program, solve business issues and get those into production and get those in front of customers as soon as possible. And when you're building smaller serverless applications, and maybe you have a few Lambda functions and a DynamoDB and SNS and a couple of things like that, it's usually pretty quick to kind of move through that process and do those developments. It gets more complex or more difficult to do as you get more complex systems, especially that rely heavily on the cloud. I am not an advocate of local development. I love the idea of having you develop directly in the cloud with sort of high fidelity, environments. I think every developer in your organization should get their own AWS account that they can go in and play with stuff and test it live in the cloud. In most frameworks and so forth, the feedback loop is pretty bad, right? It takes 6-7 seconds just to deploy a code change. If you want to deploy a new table or something like that, it can take a couple minutes. If you're deploying a CloudFront distribution, it can be 15 minutes or 30 minutes. So that feedback cycle is really, really slow. So it's not ideal to develop that way. So there's been a number of solutions where people have brought the cloud locally to try to emulate that cloud locally, things like LocalStack. Now, LocalStack is absolutely amazing. Like if you can use that to solve your problems because you're using CDK or some of these other services, I would say absolutely do that. There's other frameworks like Brian LaRue's Architect framework, which is really great, that has all of a very, very good local development experience. SST has a cool thing where they invoke the Lambdas locally and you can test stuff. So there's a bunch of people that are doing things like that. But there's still, I still think there's a tremendous amount of fragility when you do that, because again, does it work on my machine? Or when people say it works on my machine, like, it drives me nuts. Like, well, sure it works on your machine because you're running it on your machine and you built it for your machine. But what happens when you distribute this to the cloud with 258 edge locations and all that kind of stuff? How does that actually work? So I think that there's a bit of a disconnect, and certainly as teams grow, it becomes harder and harder to sort of build and test serverless applications without you setting up a bunch of things locally, having complex deployment pipelines, trying to figure out how you do these testing things. If you're waiting for those feedback loops, it can be very, very frustrating. So it's very, very powerful, but it's also very, very complex, and I think that is a big frustration for a number of developers.
Yeah, for sure. Absolutely. Some of the tools you've mentioned, SST, Architect and stuff, I have played around with those, just putting out my own functions, testing here and there. And I agree, they really give you a pretty good experience. I've also developed directly on on the cloud, just developing right in the environment. And I do agree with you. I like developing there because then you get that good feedback directly on the environment that you'll be putting it out on.
Right.
When you develop serverless applications right now, or when you're working on writing any sort of tests or whatever, is that how you're developing? You're developing right at the source, or do you tend to do anything local?
Yeah, so for the longest time, early on, I was a serverless framework user. It was very early serverless, a serverless developer. So serverless framework came out like right away. It was originally the JAWS framework, but it became serverless. Sort of serverless.com almost coined the name serverless in a sense, or at least brought it to people's attention. But they were very early on with allowing you to deploy functions, deploy Lambda functions. This very simple DSL, the serverless.yaml files. And so that's what I started using early on. API gateways introduced, they started adding all kinds of other capabilities. And serverless framework was really the leader, I think, when it came to that. So I was very much so into the serverless framework. And what I would do is I would often, I wouldn't try to emulate things locally unless it was something very simple, unless it was just a API call or whatever. But I always would set up a test account or a dev account that I would be working in, and then I would just do the function deploy. You can deploy just function code, right? And if you had to make some sort of infrastructure change, you just have to wait for it. But I always loved that experience of being able to deploy in the cloud and have the ability to test, like, what happens when I upload an object into this S3 bucket and it kicks off this thing? Or what about reading off an SQSQ? Like, you can't really do that locally, at least not in a way that gives you that true sense or the actual experience of running an application in the cloud. So I've always found the delay that I needed to add in order to get that fidelity. I always felt that was worth the trade-off. But that's actually one of the things that we're doing at Amped is we said, it's worth the trade-off, but you shouldn't have to wait for it, right? Because developers we're finicky. Like we're gonna move fast. Like I can't wait, to deploy something to the cloud. Like I want to go fast. And so we started this technology that we built at Serverless Cloud, and then we spun off, and we're using it at Amped. We've actually even done some interesting things with it as well. Where now what we do is we sync your local environment to your developer sandbox running in the cloud with the same fidelity as your production environment. We actually do that in about 300 milliseconds. So from the time you save your code to when it's synced and deployed and available to test, it's almost instantaneous. So, I mean, by the time you switch over to your browser or jump over to Postman or Insomnia or whatever to test that endpoint, it's already up and running. And so that's one of the things that we've been trying to do is just like, I mean, we don't consider ourselves a developer experience company, but that's really what we are majorly focused on, is making it easier to build serverless and cloud applications. And if you give me a second, I would point out the fact that, another sort of frustration of mine has been, okay, I have a service that I need to run. It's an API endpoint or it's an API call. It needs to process something. Having that run in a Lambda function is great. You get to a point where now your TPS gets over maybe 14, 15 requests per second, and suddenly it gets a little bit cost prohibitive. Like if you're got sporadic traffic, then running things on Lambda functions are great. Now you get the cold start every once in a while, and again, those costs can get down, but you can get to a point where when your TPS gets high enough that actually moving over to containers makes sense, right? And the issue is that it's not this portable thing where you say, well, I'm just going to move my code from a Lambda function over to a container. And the same thing is true of, like, let's say that I have a ETL task that I want to run. Maybe I run it a couple times a day, every night, whatever it is. So if it runs in less than 15 minutes, well, okay, I'm going to write this. I'm going to run it on a Lambda function. It's actually cheaper to run it on a Fargate in a Fargate task. And it can run for as long as you want it to, right? So you don't have to worry about that timing out after 15 minutes. And so you have to now start thinking, and of course with Edge, you can't, if you're using V8 isolates, you can't make certain HTTP calls and some of these other things, right? So there's all these limitations that you have based off of the different choices you make. And that's one of those things that for me, that was always frustrating. It was like, okay, I built this thing, it runs in a Lambda function, that's great. But then suddenly I add some more work to it, and now it's got to run for 18 minutes or something like that. Or, I've got this high velocity webhook and it's just costing a lot of money to run this on Lambda. Like, it would just make more sense if I could just throw it into App Runner or Google Cloud Run or something like that, because I'm going to get better performance, I'm going to get lower costs, I'm going to reduce the cold starts. Like, it makes sense to make these sort of changes. But the developer has to make that decision right now. You have to decide, do I want to put this in a Lambda function or a Fargate container or this or that? And if I put it in a Fargate container, then I lose the ability to maybe, read off of a stream with it, or I have to change the code in order to make that work. So there's a whole bunch of things that affect those decisions, but you kind of have to make those up front. Whereas we look at it and we say, why can't you just write code and then have the system figure out what's the best compute platform to put it on and how to optimize it? So that's one of the things that we've done with Amped, and we're hoping that this approach is something that other people will eventually adopt, is to say, the cloud itself is a complex system with all different types of compute and managed services and things like that. All of them specific, sort of developed for specific use cases, whatever. It's very hard for a developer to figure out what the right use case is sometimes, that they're trying, or what the best service is for their use case. We want to kind of do that for you so that you can just write your code. You say, look, I want to go ahead and run this every day, or I want to go ahead and process this webhook, or I want to, run on this stream or something like that. And that those things will just sort of be figured out for you without you having to make those decisions up front.
Yeah. I'm just thinking through a bunch of different things as you're talking, wishing we had all day to talk, because so many things I want to talk about. But I think one thing that really stood out, though, and I'm curious what your take on it is, you mentioned like sort of the vision at Amped is to be able to write your code, deploy it, and have the infrastructure kind of figure out what the best services are to use for it. That makes me think of, I don't know if you've seen Swix's idea of self-provisioning architecture or infrastructure, I think it is.
Self-provisioning runtimes, yeah.
Runtimes, yes, that's it. So does that sort of play into the idea that you're talking about there? Is that sort of what you're reaching for?
Yeah, it was actually funny. So we launched Serverless Cloud in 2021, I think in September of 2021. And shortly thereafter, Sean Wang, Swix, wrote that article about self-provisioning runtimes. And we saw it, and we sent him a note. We said, hey, this is almost exactly what we're doing at Serverless Cloud. And so he was immediately like, yeah, he's like, I didn't even know you guys were doing this, but he was super excited. So yeah, so we know Sean very well. And yeah, he's very excited about what we're doing, at Amped, because that is this idea. It's sort of like, we look at the cloud as sort of just a big computer. It's just a big distributed computer, and it's got all these subsystems in it that do all these really amazing things, and they do them really, really well. But somebody, in order to actually coordinate all those things, you have to write essentially machine code in the form of CDK or Pulumi or Terraform or whatever. You have to give the cloud instructions as to how you want all this stuff to work together. So we look at Amped as almost like an operating system for the cloud, where you get a higher level abstraction, and that a lot of these other things in terms of coordinating subsystems and figuring out the optimizations are done for you, so that you can focus on just the things that you write. So it's very similar to the idea of self-provisioning runtimes. We don't necessarily consider ourselves a self-provisioning runtime, but the idea is that our deployment system, our deployment engine, calculates what it is that you need and will deploy those services for you. But yes, but essentially that. And again, I think that absolutely is the future. Like, why do you still write machine code for the cloud? Like, I know we're still early. I know there's been a lot of iterations on it. We're always adding new services, but yeah, it just seems like, we figured out 99% of the use cases and what the best practices are. Why are we reinventing them every single time you go to launch a project in the cloud?
Yeah, no, that's great. And I think what we're going to do is, when we get to the panel section, I want to talk a lot more about this, so that people,
yes, absolutely,
listening can understand what the self-provisioning runtime even means. Because I do think, and at Prisma, we totally agree that that's the future of where things are going. I think that's a lot of the hype around serverless and edge is pushing towards that exactly, where you can focus on writing your code, you can deploy it, and you can be sure that the best architecture for your specific application is chosen. So we definitely want to talk about that a bit more later. Another point you made before is just about the speed of iteration when you are developing serverless applications and just clusters of infrastructure and all of that. Especially with Prisma's, user base, the audience that we normally get, we have a lot of TypeScript and JavaScript developers. Yep. And in that world right now, you see people moving from front end and back end developer positions to full stack, because those are sort of being combined in most frameworks right now. And as JavaScript and TypeScript developers, we rely and we very much expect very quick iterations where you can just write code, run it right away. You see tools like Vite giving you, sub-millisecond rebuilds of your site. And it's so this whole idea of developing on serverless and having to wait for these maybe deployments or infrastructure changes to take place is kind of scary, I think, when you're a TypeScript developer coming into this world, especially if you're coming from the front end side of things and you're just learning to get into the back end. Do you see in the near future that changing at all in a positive direction? It sounds like it has been already, but do you know of any other developments that you're excited about maybe that can push this a little further?
Yeah, I mean, first of all, I'm a huge fan of front-end developers, because over the last, 6-7 years, whatever it's been, I think front-end development in JavaScript, TypeScript is more complex now than back-end development in some of these things, just because there's a lot going on there, but yeah, I absolutely agree. And I mean, in many cases, whether you're using React or Next or SvelteKit or any of those things, that feedback loop, how would you even, I don't even know what you'd do if you make a change to a style and you have to wait 30 seconds for that to refresh. I mean, that would drive you nuts. I mean, as a back-end developer, and as a pseudo front-end developer, I try to be. But as a back-end developer, yeah, I mean, that's something I think a lot of people just sort of got used to, right? Was this idea where it's like, okay, hit deploy, go grab a cup of coffee, play a game of ping pong, and then we'll come back later when it's there. I think certainly if you are used to that fast feedback loop, that moving to the back end and just having that painful painfully slow iteration time in the cloud is something that you certainly are probably not going to want to deal with for very long. So, I mean, there are, like I said, SST has that sort of live Lambda reload or something like that. I forget exactly what they call it, but the ability to process your Lambda, at least your Lambda code locally with some remote calls. And then, with obviously Amped, that's one of the things that we're doing is the super fast feedback loop so that you don't have to worry about that. But even AWS has a service called SAM Accelerate, where essentially if you make a code change and you're using SAM with the serverless application model, which is sort of a flavor of CloudFormation to build your serverless applications, then if you're running SAM Accelerate and you make a change, it'll go ahead and zip your code, upload it, and deploy it. It takes about 5 or 6 seconds, but again, it does it automatically for you, and it is it's a pretty nice experience. Even Serverless Framework has a thing where they'll do a live reload of your remote code, and I think it's like 3 to 4 seconds. So that's not ideal. It's not perfect if you've got to wait a couple of seconds, but we're obviously, there's different ways in which you can speed it up. So I hope, at least I hope that people embrace the idea that says if we can figure out a way to make these feedback loops faster, and I know we have it Amped, then that will become the standard, because that is something that is just not going to fly if people have to wait. And the thing I'll say about, again, local stack, nothing against them, an absolutely great product. They've done an amazing job bringing as much fidelity as they possibly can. But it's installation. It's a lot of stuff you have to do. Even things like secrets and other things that you might have stored in parameter store or things like that might need to get pulled into your application, or like extensions. One of the things Alex had mentioned, the RDS proxy and some of these other band-aids. One of the things that I actually built a while back was called Serverless MySQL, and what that did was essentially, after a call was made, or I think it was sort of a cleanup, once the function ended, it would make a call and check to see how many open connections there were, and check the idle time on those connections, and it would actually do a connection cleanup for you at the end of every call. And then if it tried to make a connection and it couldn't get a connection, it would retry. It would use jitter, and then there would be a thing that if you were over the connections, or there were too many connections, that it would just kill the connection of the previous one. It actually worked really, really well. I was thinking RDS proxy would be the solution to that. But what I've seen other people doing now is using like Lambda extensions to close the connections once the Lambda lifecycle closes. Other interesting things. Here's the problem. Shouldn't have to be building that yourself, right? Like there should just be a solution for these things, that would make it easier. So I think that, a lot of these databases that are coming online now, or that are around, I mean, the Planet Scale is very, very cool. Tigris is very, very cool. There's some cool services. Memento is awesome, for the fact that you don't have to have, that it will just scale up and down. You don't have to worry about connections and things like that. Those are very, very good characteristics because of the type of compute, and the separation of invocations, or the isolated invocations like Alex was talking about. Those are very, very good things, right? And so those are solutions that are great, but I still think that, people are going to still want to connect to their own databases, especially when it's enterprises and they have all kinds of requirements that they need to do. And so serverless and these tools have to get better to make the stuff work for you. So yeah, I mean, I still think there's a long way to go. I mean, we're nowhere near where we need to be, but I think we're getting there. And to go back to your original question, yeah, I think it is going to change. I think it is going to get better. And I hope that, as Alex said, rising tide raises all boats, right? Like basically, people that are just chipping away at these things, it kind of brings up what the table stakes are, right? Yeah. So as the table stakes increase for new products entering the market, or people that are working on things, I hope that some of the table stakes have been raised even for cloud companies, right? So Amazon or AWS and Google Cloud and Cloudflare, like other startups are raising the bar, and these companies have to follow. And I think that will be that'll be a good thing when we get to that point.
Absolutely, absolutely. Awesome. Yeah, well, I think this is a lot of good insights, and I do think that we're going to have probably a lot of things to follow up on this in the panel for sure. It looks like we're getting close to time, so I think we should switch over to there. But by all means, if there's topics you want to expand upon, bring them up at the panel, because that'll be good stuff.
Awesome. Thank you.
Yeah, thanks for having this little chat. I'll do a little transition, and we'll get the rest of the panelists up here. Hello, everybody. Full board.
Hello.
So to start this off, we've heard from myself, Alex, and Jeremy already, but we now have Tyler up here as well. So if you want to just quickly introduce yourself, and we can get started.
Yeah, for sure. Hey, everyone. I'm Tyler Benfield. I'm a senior software engineer here at Prisma. I work on our Prisma data platform, so tools like Accelerate that we announced relatively recently, and some upcoming tools that we've teased a little bit. Those are part of my team. I'm really excited to talk more about serverless today.
Awesome. Yeah, no, definitely some exciting stuff. So we'll hear more in the future. But yeah, so I just want to go ahead and kick this off with just sort of a question to spark some conversation. And that is just the ecosystem in general right now around serverless. What excites all of you guys the most? What's the up and coming things that really get you excited?
I mean, I can go first. I sort of spoiled it in my talk, but like I am sort of excited about what's happening in the data space and just the different options there. Like solving the connection limit issue is like a really nice thing. And then just like truly seeing some like more cloud native databases and things that are built for that, from day one. I think it's pretty exciting. I'm not sure, like I've been excited about this before, like Aurora Serverless, I was super pumped about, and maybe I'm just an eternal optimist on this, but it does feel like a new type of, a new wave that's coming in and some of that, and just the momentum we're seeing in the database layer, I think is really exciting.
Definitely.
Yeah, I would agree with, I call it the database space race, the cloud database space race, something like that. But I think that it is really interesting to see. And it's funny because, when Planet Scale, I mean, Fauna came out a while ago, CouchDB was out a while ago. And it was kind of like, okay, right, who's going to use an external database service, right, to do this stuff? And then, then Planet Scale, and you're like, okay, this is kind of cool. And the idea of branching and some of those other things, right? Then, then it's Zeta and then Neon. You're like, okay, apparently this is where, we should have done a database. Alex had mentioned the Terso. There's also Cloudflare's D1, I think it's called, which is their distributed, their distributed SQLite stuff that they're doing. So, I mean, that's the thing that is interesting to me, because I always feel like a lot of us, especially people like Alex and myself, we talk a lot about like what's cutting edge, like the things that are there versus the things that most people are probably using. And I mean, I'm excited about the edge as well. But the thing that's interesting about the edge when it comes to data is there's not a lot of distributed databases that are replicating to all these different places, right? I mean, DynamoDB, you can replicate to multiple regions, but it's kind of expensive. It takes a while to do, right? It's not great. And then even if that's the case, your edge functions still need to route to that region that's closest to them in order to pull that data. So again, you're not solving the speed of light problem here. And honestly, it's one of those things where it's like, let's say a user signs in. Do I really want to replicate my user sign-in, table to 26 regions across the world? Yeah. Or can I deal with 300 milliseconds of latency when they sign in, right? And then maybe I can use a local authorizer and cache that locally or something like that that would speed that process up. But I think that is, one of the fundamental things where I think people are getting a little bit confused with the edge is that it doesn't solve all the data. It doesn't solve the data problem, at least not yet, right? And that's something that it's great if you can do some IP checking. It's great that you can call like even calling local caches or caches that are close to the edge the edge endpoints themselves. That's nice because then you can do things like rate limiting, and you can do some really really cool things with the edge. Like, don't dismiss that. But when it comes to like actually pulling user data and things like, other than caching it locally, is something that I think we're not there yet, right? So I mean, getting too excited about it, and I still go back to the developer experience. I'm big on the developer experience, like deploying all these different the same service to all these different regions, coordinating the data, understanding where that data is, and caching. If anybody I mean, I think we all know caching is one of the hardest things to deal with. I had a sign above my desk at my old company that said it's a caching issue, and then when anybody would ask me a question, it's like, why is this not working? I just point to it. It's a caching issue. That's just what it is. And so like there's just so much more complexity that's added when you start distributing these things around the world. So I'm excited for the connection limit things, like Alex said, and for the ability for you to scale very quickly. And I think there is going to be regional replication that is going to be important, especially for data requirements and some other things. But I think overall, we're getting a little bit ahead of ourselves in terms of what the use cases are going to be for this in the short term.
Mm-hmm. For sure. Yeah, I know we at Prisma understand the caching issue a lot with our Accelerate product. Tyler worked on that a bit, right, Tyler?
Yeah, definitely. I've dove pretty deep into that, and that data issue is a really interesting one. I think we shared on Watson with Prisma something along the lines of, we can't fix that speed of light problem. We can't fix the distance between your data, but thinking about it from a different perspective of what things can we fix, what can we move to the different sides, and it kind of leans into some of the tooling discussions. I think of the tools are getting better and trying to provide services that can make that decision for you and say, well, this data should live close, this data should stay back at its source, and then maybe there's somewhere in between. So that's what I'm really excited for, is the services that come up and the tools that come up to sort of address those concerns. Like we're getting, I think, a potential better user experience by moving things to the edge, but it introduces a whole other flavor of problems that we now have to solve. And I think there's companies and services coming up to solve those problems.
Yeah, for sure. Absolutely. And something you just said gives me the opportunity to shill once again the self-provisioning runtime. So I think this would be a good time to bring that up, given what you just said, Tyler. How do we define that here? How do we all collectively define what the self-provisioning runtime is and what sort of the goal of it is?
Yeah, I've got some ideas on that I've read the post, and I'm really interested in that idea that it kind of boils down to, as developers, ultimately, I think we just want to ship products. We want to make users happy. We want to deliver value. Same as businesses, right? I think it's stepping back from that. Well, a prerequisite of that is we have to write some code. We have to chain some things together to make something useful. But that doesn't necessarily include building infrastructure. And it's kind of a side effect that we do that. Even the code is almost a side effect to some degree, but the infrastructure is definitely a side effect. So I think if we work back from that, having it where we can write the code and not think about the infrastructure, and the right decisions are made for us, and we can focus on the business value, and then we can look at what's in the future of that. How do we get even faster at delivering that value?
Yeah, I think the big piece of it too is that there is no silver bullet, right? So an edge database might work in some cases. A regional database works better in other cases. Relational database versus a NoSQL database, some form of compute versus another form of compute. They all make sense in different situations based off of, and not even necessarily the use case, but maybe the volume, maybe the amount of traffic they're getting. Like these things have to be adjusted based off of those things. And those are just decisions I think that your average developer, I mean, even your advanced developers, can only know so much, right? And that having a whole team of people to try to figure out what's the best way to optimize this. And I think we all know, especially anybody who's ever worked at a startup, like, premature optimization is just, you don't even think about it. Like, let's just build and ship and build and ship and try to do as much as we can, and as securely as we possibly can. So I think the idea of adaptive architecture, where, essentially it is, you have a problem you're trying to solve. I want this to do X. How it does it should, is a concern now, but should it be, right? Why isn't the cloud smart enough to figure out that it needs to use this type of resource? I mean, even things like if you're familiar with Lambda Power Tools, for example, excellent little service where you can run your application, your Lambda function will try out all these different memory settings and so forth, and try to give you a graph of sort of where cost and performance meet. And then you can choose that and say, okay, well, I'm going to use 1536 or whatever that number is, megabytes of RAM for this, or of memory for this particular function, because that's the sweet spot. Why do you have to figure that out manually? Why can't the cloud just look at what is happening? Why can't the cloud say, this is running kind of slow. What if I gave it a little bit more memory and then test that optimal thing? That's where we have to get to, right? And I don't don't think AI is necessarily the ultimate solution here, but I do think that using machine learning and using just standard patterns that can be automated, why aren't we doing that automatically? And I think that's what the self-provisioning runtime is really about. It's about saying, write the things that matter, and then when it actually comes to optimizing those performance, rather than, again, reinventing the wheel at every company trying to figure out what the best way is to optimize this, just have it built in, have it automated.
Jeremy, how do you, I guess, address like the trust issue people have, like, wanting to be able to like have control of that? Like, is it the same sort of trust issue of going from like, hey, I used to be able to reach out and touch my servers, and now it's, it's some sort of function compute running somewhere and things like that? Is it that same sort of transition that we need to have there?
Yeah, I mean, I think one of the things that we've seen, I mean, certainly when I was a lowly web developer in my dorm room all those years ago, I used a hosting company, and I got an FTP, and I would just FTP things to a CGI bin and whatever, and I didn't have any control over the server, right? Then Plesk came out and cPanel, and I could start, installing some things. I had a little bit more control, but it was all through an interface, right? I didn't have, raw access to the server, and then suddenly, in order to accommodate enterprises and the larger companies that could do the lift and shift, the cloud probably made the mistake, although it worked, obviously, because they got so many people to start transferring into it. But the mistake was probably saying, oh, it's just a remote data center that you have full access to the servers. Like, that was probably a mistake. If we would have stayed with the sort of hosting aspect of things, where it was more like, here's a control panel, here's your AWS console, here's how you control your things, and you didn't necessarily have that raw access, that might have been a step in a better direction. But I think that what we've gotten to is now everybody is so used to turning a bunch of different knobs, even though a lot of these knobs don't do very much, right? I mean, there's very little control that you actually have in the cloud. That little sense of, I can do this, I can make this choice, I can make that choice, has sort of given people the impression that that's what they need. And so I think there's a bit of a re-education, but I also say it's a very small fraction of developers who are building in the cloud, right? Most people are still on-prem or using other services. Even people that are using DigitalOcean or using, the Heroku people, things like that. Those are all services that I think took away a lot of that operational, that control concern. I think we can get back to that, but I think that it's going to be a matter of being transparent and say, here's what we did, audit it if you'd like to, but I think eventually we'll get to a day where, is anybody asking how Vercel does it, right? Is anybody asking how Netlify does it, or some of these other services? I think we should be asking those questions, but is that the kind of thing where we have to that people are necessarily concerned about it? And I think if you deliver on the promise, and that trust will come soon thereafter.
Absolutely. Yeah, those are some great points, and I think it's a kind of a funny relationship looking at it from the outside that people want this granular control, or at least a granular view into what's going on in their systems. But at the same time, those same people are thinking, man, some of this could be automated. I wish it could just do this automatically. But then when you offer it, it's like, oh, whoa, what are you doing to my stuff?
Right.
So it's like,
what's happening here?
It's this weird sort of limbo that we're in right now. I think, just like you said, because of the granular amount of control we were given that maybe we shouldn't have had, because it's stuff we do manually that could be done for you. So yeah, kind of funny to see how that's playing out and how we're going to have to push through that.
Yeah,
right. Well, sorry, go ahead, Tyler.
I was going to say, with some of that control comes risk, right? Like, when you give up some of that automation, you introduce the chance of making a mistake and deploying a mistake and affecting your users. And I think that's sort of a balance I've learned over time, is that when I used to want a lot of control over things, I wanted to be able to move all those levers. And I moved more and more into the state of, I don't want to have those levers available to me. I want someone to make that decision for me. Yeah. And I want my stuff to just work.
That's sort of the point that I was going to make, is to say that, look, society has very much, like, a long time ago, psychologists figured out that people want the illusion of control and not actual control. If you think about it, the elevator close button doesn't work unless you put the key in, but people press that all the time, and they hit it like 10 times, the door finally closed, and like, okay, it worked. It didn't. It has nothing to do with it. But if people just stood there waiting for the elevator door to close, they'd probably go crazy. It's like when you hit those crosswalk the button on the crosswalk thing. I don't think that has any effect on whether or not it changes the lights or not. Those are all timed timed based off of intersections up and down the entire, multiple blocks, right? So you're going to get the walk signal when the walk signal wants to give you the walk signal, not because you press that button. And I think that the point is that giving control introduces a lot of chaos, right? If every time I hit that walk button, then suddenly the lights turn red and I could cross the street, or every time I hit the elevator close button, the door's shut, you can imagine somebody stepping in and then hitting that thing, and then now you're inefficient because you're only carrying 2 people up, 30 stories than the 15 people that could possibly fit on that elevator if it actually waited however many seconds to close that door. And so when you go in and you give somebody this memory control, even on a Lambda function, like there's a lot of risk in that. Like, oh, well, you can turn it up to 10 gigs now. Well, that might be a stupid idea, because if you're only doing network IO, you need 128 megs of memory. You don't need 10 gigs, right? So you're spending all this money on stuff that you don't need. And in most cases, you probably don't understand why you would adjust that and what the optimal setting is. So yeah, I think that you're right. The more control you give people, it is funny because we always see this. We always see people that they'll build their own logging solution. Like, why did you build your own logging solution? There's like 40 observability companies out there that are all begging you to use them. Like, I mean, these are the things that we, that we look at and we're like, yeah, some of this stuff, if you take it off, I mean, maybe we just give people placebo buttons so that they can hit those and feel comfortable with it, but then actually, say, well, we know you wanted to do this, but this was the safer bet to do that. And I think that's the thing for me that is a little bit scary, is I think people that control, it can have a very negative impact if you don't understand what it is that you're actually doing.
Yeah, it's like that whole drama going on right now about, rolling your own off. Like, is that good or is that bad? Like, what do you do?
I'll go on the record. Rolling your own auth is a terrible idea in almost every circumstance, until you get to a point where you're like, you've got a team of security experts that understand what's going on. It's so cheap to just use Cognito or one of these other ones for a small amount of users. That's the way to do it. And look, I know someone had made the point too about having your database, your user database, so you can join on your user database and do some of those things. Yeah, if you're building a small monolithic app, like maybe that makes sense, but I can't think of a service I've built in the last, 5 years that didn't have a separate user service that was completely independent of all the other services that were using it. So I wouldn't be able to join against those tables anyways. Again, I'm not sure why you necessarily need to. If you're doing reports, then you export that somewhere else to a reporting service and so forth. But there's ways to accomplish that when you're building microservice architecture. But
yeah, for sure. So thinking about stuff like this along the lines of this self-provisioning runtime, in the article that we're talking about, Sean sort of presents a spectrum of, you have infrastructure on one side and code on the other side, and it's trying to find that sweet spot. And I think this is what he's getting at with that, is that we need sort of the illusion of control. So you can control things through your code, but we need it to still deploy and run your applications in the most efficient way possible. And so I think sort of what we're discussing here is just like, what does that sweet spot look like? How do we give people the amount of control that they feel like they need while giving them the best applications and the best performance that we can have with the products?
I've got plenty of thoughts, but
I was going to say, Jeremy, you've thought about this way more. Like, you're building this thing. I don't even have enough to think about this. Like, tell us how you think about that trade-off in Amped, right? Like, of giving that. Yeah.
Right. I mean, it is one of those things where it's like, how much. First of all, there's a difference between sort of like application code and business logic, right? It's a thin line, but there is a difference, right? I mean, business logic is usually about your business objects and what's happening with those, whereas the application logic is actually the implementation of the business logic and some of those things. It's not the greatest explanation, but essentially the thing is how much do you want these two things to creep together? How much do you want to separate them? I talk all the time about the bifurcation of business logic, where you put a lot of business logic into your application code, but then with things like CloudFormation and what we call configuration over code, where you start maybe separating, filters and maybe end-to-end, point-to-point type translations of data or transformation of data. You start separating that into, CloudFormation or using some other, DSL to do that. now it's like, well, some of my business logic is here, some of my other business logic is here. And the point that I was in Australia for Serverless Days ANZ, and somebody made this point, which I thought was brilliant. They're like, I feel like a lot of this stuff is like stored procedures. And since we're talking about data, maybe so many people will get this reference, but how many stored procedures have we written in our lives? Maybe you're all too young to do that, but I know I wrote a lot. And the problem with stored procedures where it was great. It's like it was almost like a Lambda function in your in your SQL database that would do these things for you and just spit out a result. The problem is that they became intricately woven into every bit of your business logic and code. And then suddenly it's like, well, how do we change this? It's like, well, the query's not there, so where does it go? And then I make a change to my schema, and then suddenly a stored procedure isn't working right. Like, there's just so many interesting things about that analogy where I'm like, it seems a lot like it. If we start separating different parts of our business logic because we say, oh, well, this will work here if I put it into my CloudFormation, but I got to do this here in my code, or maybe my code has to be in my CloudFormation because it's a JavaScript, resolver in AppSync or something like that. And now where is this code? How do I make those changes? How do I deploy it? How do I test it? Right? How do I keep track of all these different changes and what might break along the way? And that bifurcation to me is a little bit scary. And so if you cut out that configuration piece and you say, well, if you can express what you want to do in application code, even if there has to be some sort of layer of an SDK or something that helps with articulating what it is that you want, I still think it's really good to have it all in one place. The question is whether or not that code can be translated into the magic that the cloud provides you by bifurcating this business logic. And that's what we're trying to do at AMP, is we're trying to say, can we take everything that you would want to do, identify it within application code, and then translate that in the right way to the cloud services that are available that do some of these amazing things and dramatically cut costs and give you all kinds of resiliency and things like that. So that's how we're looking at it. So again, the trade-off to us is, I don't even know what I want to say it's a trade-off. It's sort of like, our goal is to eliminate configuration separation, the idea of having to think of these things differently. Think of it in use cases, think of it in business logic, and then let a system translate that into the infrastructure that's needed to run it.
I love that comparison to stored procedures because, I'm still in the sort of preamp world of configuring a bunch of stuff and all that stuff. And I just tend to avoid a lot of those sort of extra cloud features that feel more stored procedure. Just a few examples I would say would be DynamoDB stream filters, right? Where you can filter out data and stuff. It's usually cheap enough just to filter those out in your actual business logic that I'll do it there, just so you're not relying on some of these cloud features. So I agree, but I'm also eager for something like AMP where I can write that in my business logic, and whether it's translated into my application code or something
shouldn't matter to you
as part of the infrastructure, just the centralization of that, and not sort of having to jump across files and config languages and things like that is exciting.
Yeah, Jeremy, what you're describing reminds me a lot of sort of the abstractions that languages like SQL and then ORMs give you, where you have your raw database, you write SQL as your blueprint of the data that you want to get out of there, but you don't tell it what all segments of your disk to read. You don't tell it which indexes to use. It has all that engine and smarts to make that decision optimally for you. And your job is to describe the data. And then you have another level on top of that of ORMs that can define, well, I want to write this now in my language of choice, and I want it to become a data structure in my language. And then that becomes the SQL, which becomes the raw operations. It feels like that for an infrastructure concept.
Yeah, that's a really good point. It's some people obviously do, but do we as developers working on these applications ever question what's going on in the database engine, deciding where to grab all this data? We don't. We just trust that it works and that the people who built it know what they were doing and are giving you the best possible experience there.
Well, right, and you're encapsulating business logic oftentimes, especially if you're using ports and adapter, or you're doing hexagonal architecture where you're saying I'm not even necessarily going to give my developer raw SQL, right? I want to use something like an ORM, or I even if I want to build my own data adapters. Like this happens all the time. People are like, oh, well, we want to have a get user function that'll query the database, whatever that is, and return back a standardized object. And that's written and it's codified somewhere, and then that's imported, and people use that as a shared resource. And whether that might even use an ORM behind the scenes as well. Like there's all these different layers of abstraction that people just build, and then it gets very, very hard to deal with some of those things. And I think that there's a necessity to some of that stuff. But like even when you look at like DynamoDB, for example, if you're interfacing with DynamoDB, it seems pretty simple: get, set, and delete, right? Like those should be pretty simple things. But when you query, right, you have a very complex. It's not complex, but it's more involved query language in order to do certain things, right? So the idea of being able to even simplify those, almost every project I've ever seen that uses DynamoDB, somebody writes a DynamoDB adapter that that codifies the queries and basically build an ORM, for that. And then it's like, well, now I need some other value, and you got to go in and change this thing in this ORM, and then the data comes back a different way to other functions. You're like, well, this isn't right. So I mean, there's just a lot of stuff that gets really, really complex with that. So I think that. I don't even remember what we were talking about at this point. I'm sorry, I just get excited. But yeah, I mean this idea of using these abstractions, people are going to build abstractions anyways, right? So almost nobody is going to use these raw interfaces. Like nobody's signing their own what is it, the V4 AWS SIG stuff and calling the APIs directly. They're using the SDK because it provides an abstraction. And then what do people do? They build an abstraction on top of that abstraction, and an abstraction on top of that abstraction. Like if we could standardize those things so it's a little bit smarter, again, it makes it makes a lot of sense to me.
I will say we're coming up on time, so we'll probably wrap up conversation right around here. But if anyone has any last things that they are itching to get out, feel free. And if not, we can call it here. I love the conversation we've been having. I hope that we continue this on social media, get other people involved, talking about this stuff, because I personally, and I know Prisma as a company, we see this whole idea that we've been talking about as the future of where development's going. And I think just sort of the concepts we're talking about are things that people know and realize are important in the back of their head, but they haven't really found a way to articulate it to themselves yet. And I think this is just the messaging around here is something that we really need to push out more as the industry sort of pushes that direction.
And actually, if I can make one more point too, I saw a criticism of serverless recently that was like, if you need a tool in order to coordinate all of the things that are happening, right? You need whether it's serverless framework or CDK or any of these things to coordinate all this stuff that's happening, that's not necessarily a good thing, right? Like it should just be clean and easy to deploy. And I think I mentioned this with you, Sabin, about the idea of, 1,000 Lambda functions gets very hard to manage. But I think that's thinking too small, because even if you're deploying to Kubernetes or containers or any of these other things, there's a tremendous amount of orchestration, right, and choreography that goes into making sure that all these things can talk to one another and all the ACLs are right, and that that you're that it can discover all the things it needs to discover. And so the cloud is just complex, and there's a bunch of necessary complexity in the cloud. I think the trade-off to that, the benefits that gives you, is absolutely amazing. The power that it puts in the hands of individual developers and small teams, it lets them compete with the Facebooks and some of these other massive organizations out there. So I think that trade-off is worth it, and I think that, again, if you're still thinking about building on a single server, right, or maybe you got your MySQL, installed next to your Apache server or something like that, then you gotta look at where we are now and where the stuff is going. Yeah, it's more complex, but having tools that can coordinate the stuff for you make your life a lot easier. And again, that benefit that you get from that, I think is absolutely game changing.
For sure.
I agree. And I would just say, like you said, there's some necessary complexity of the cloud, but there's also a lot of like additional complexity.
Right.
I'm grateful for the JavaScript ecosystem. You like mentioned that earlier, but like the great thing about the JavaScript ecosystem is they will like seriously plant millions and millions of flowers, and only some of them will bloom. But like we'll figure out the right DX for this stuff. Like both of these companies here and Prisma are like doing a lot to push this forward, and there's just a lot happening in the ecosystem. I'm grateful for all that.
For sure. Yeah, it's great to see the community developing around this. And I foresee it just getting better and better as time goes, especially over the next year or two. Yeah, thank you guys so much for coming on. This was some great conversation, and we just appreciate you joining our first episode of this. I think this sets the bar high for future episodes we have, and we would love to expand upon these ideas in the future ones. So thanks for joining.
Great to be here. Thank you.
Great. Thank you.
For everyone watching, we have links to all of the socials for everyone up here in the description. So please, if you got value from any of this, like go follow everyone here. Everyone posts great stuff and really insightful full stuff like this all the time. So I definitely recommend that. Also, anything that we talked about during this, any links we brought up, like the self-provisioning runtime article and just other various things, I'll be linking those afterwards in case you want to go back and read those. But yeah, thanks for joining, everybody. I'll transition again really quick and we'll close this thing up.
See y'all.
All right. Yeah, that was a super fun session. I appreciate everyone who came along to watch. This was really insightful. I learned a lot, and it gets me really hyped for the next episodes that we're going to have on this. And speaking of that, the next one is going to be March 23rd. It should be at the same time as this one. And then from there, we'll figure out the schedule of the cadence of this, but this will be sort of an ongoing series. So yeah, thanks for joining. If you have any follow-up questions, feel free to keep commenting on the video. We'll come back and check. And like I said, any links that we talked about and any social media links that we mentioned and all of our socials for the people who are up here will be in the description as I update that afterwards. So yeah, again, thank you so much. And we hope to see you join us on the next one.